welcome everybody to join the international lecture series. This is Lingyun Yu from Xi'an Jiaotong-liverpool University. It's my great honor to introduce the speaker today, Professor Wolfgang Aigner from St. Polten University of Applied Sciences. The topic is about time visualization, so I will give a short introduction about Professor Aigner. Wolfgang Aigner is the scientific director of the Institute of Creative and Media Technologies at the St. Polten University of Applied Sciences, Austria, and adjunct professor at Vienna University of Technology, Austria. His main research interests include visual analytics and information visualization with a focus on time-oriented data. Professor Aigner received the PhD and habilitation degrees in computer science from Vienna University of Technology in 2006 and 2013, respectively. All right, so now let's welcome Professor Aigner to give us the talk. Professor Aigner?
Sorry, some technical issues, but it should work now. Can you see my slides?
Yes, we can.
Perfect, perfect. Thank you very much for the kind introduction, and thank you for inviting me to have this talk here. Thanks to the organizers especially. So the topic, as was mentioned already, of my talk today is TimeViz, or the visualization of time-oriented data. And there are actually three main things I wanted to present today, or I wanted to communicate. First off, I wanted to motivate what is special about time, and what makes it worthwhile to look deeper into the whole topic. I want to give you some illustrative examples of current research that we did in research projects and their outputs. And I also want to give you like a step-by-step framework on how you could like form a process of how to select appropriate visualization techniques for this kind of data. So, but first of all, why are we all like talking about that topic? I mean, I don't like the term really that much, but it's out there, so I better use it, like big data. So as you all know, of course, like in the last decades, like our capabilities and technical possibilities to store, to collect, to sense large amounts of data, like has grown tremendously. And these data come from very different sources, like health records, real-time sensors, like also unstructured data like text corpora narratives, and also business translations. And a big portion of that data is actually related to time. So that makes it already a very important sort of data. The thing is that just like amassing these large amounts of data, that's not our end goal. So what we actually want is to gain some insight from that data, to gain an overview, to like have a basis for making decisions, to find out new things, to gain new knowledge. That's actually what we're about to do. But more often than not, I mean, the situation is more like this. I mean, you have all that data like that's collected in companies, in public administration units, and so on. And we oftentimes like are standing in front of that data and not really knowing what's in there. And as you all know, I mean, we in the visualization field, we strive for like providing tools for users to gain insights, to learn new things, to extract knowledge from that data. So that's one possibility. And that's kind of the core idea also of this area of visual analytics that is defined by Daniel Keim and colleagues as visual analytics combines automated analysis techniques with interactive visualizations for an effective understanding, reasoning, and decision-making on the basis of very large and complex data sets, kind of as the frame of it all. Of combining this automated data analysis, because like data is already too large to be like presented visually, and combining that with the interactive visualization and using the incredible like human capabilities of dealing with visual perceptual input and all these pattern matching that we have built in our brains mainly. So why am I here talking about that? So the introduction already mentioned a couple of these things. My main areas is in like time-oriented data, design, study, research, multi-device ecologies, with a couple of different application areas, and I would like pull out one or two of these also in the actual examples that are given. Just maybe a bit more about my own background. So the focus, as I said, is on interactive visualization and data analysis of time-oriented data. I have a technical background from an educational point of view, like in electronics and computer science. Did my master's and PhD degrees at different universities, and I also have the habilitation degree at TU Wien in Austria. I'm in this area for approximately 20 years now. So was involved in a number of industry and consulting projects and research projects. I'm actively publishing on these topics and also an active member of the scientific community. And like my context now is the Institute of Creative Media Technologies at St. Polten University of Applied Sciences. And just to give you a little information about where we are close to Vienna, just about half an hour train ride in Lower Austria. That's where our university is. And I'm the scientific director of one of the research institutes, the Institute of Creative Media Technologies, where our goal is to conduct interdisciplinary research on human-centered interactive technologies and media of the futures. We're a quite large research institute in our university, covering a broad range of different topics. And just to give you some ideas and examples of what topics we're working on, first thing is allowing journalists to investigate complex data as one of the application areas. Another one would be like assisting IT security specialists to fight malware, for example, or more traditional media production, like supporting TV producers, for example, to tell better and richer stories using newly available technologies that we have at our hands. Also, the medical domain is quite important in our universities, for example, helping patients to recover faster and using technology in that process, and all the way until like artistic research, where we empower artists to express themselves in new ways. So overall, there are like 4 research groups in our institute with application areas, creative industries, IT, healthcare and well-being, media industries, as well as smart manufacturing. So we're like 30 researchers plus about 20 faculty members, when having about 70 running research projects on national and international funds. And the research topics that we're working on, like as I said, they have a quite broad span from AI and visual analytics to HCI visualization, the topics that I'm mostly talking about today. But other than that, also media markets and management, media studies and ethics, media production and media art, and digital transformation and smart manufacturing. Before I go back to the main topic, just one pointer also. You're all very much invited, if you have the chance, to come here and attend one of the next conferences that we host, which is the Audio Mostly Conference 2022 at the beginning of September, which is an SCM published conference specialized on like audio technology and also sonification, which I will show a bit of, and how the relation is to visualization. So far about me and like my embedding and background. Back to the core topic of this talk today, visualization of time-oriented data. As I said, I work in that area for quite a while, and there is also a book that we published like 10 years ago on the visualization of time-oriented data with Springer. And just as a precursor, we're currently working on the 2nd edition on that. So it probably will take still a couple of months until that's going to be ready, but we're working on that. So be prepared to read a new version on it in the near future. So you might think, okay, why do you need like a whole book to talk about that topic? Like time isn't so special after all. However, when I started to look into the topic, basically starting when I did my PhD there, I was finding myself kind of in the middle of a rabbit hole of like every time I dug deeper, it got even broader. So it's a very, very interesting topic, and the more you look into the details, the more details come up after that. So it's as soon as you scratch the surface there, the whole thing starts to explode like in any possible way. Like, and I just wanted to have like a very short and very old quote of St. Augustine saying that what then is time? If no one asks me, I know what it is. If I wish to explain it to him who asks, I do not know. And you can ask basically yourselves, like, how would you explain the concept of time, or like time-oriented data, maybe if you want to be more precise there and more constrained, to somebody who doesn't know what the concept is? It is not that easy, and just really try to do that on your own. Like, describing that concept is very hard, in fact. So going back to where we were before, so our goal is basically to make data understandable by human beings, to like foster gaining new insights, to learn something, to extract knowledge. And for that, we have a couple of things we want to take into account. The one thing is time itself, so modeling time. So what are the characteristics, the specifics of time? I'm going to give you a couple of examples what that means. Of course, it's about visualizing it. So how can we find meaningful visual representations that put a human in a position to readily understand and make sense of the data or the visualization that they have in front of them. There are special interaction techniques. It's always a dialogue between like a visualization and a human being. It's not like a report infographic that we're heading at, but we want to have or foster an interactive dialogue between a computer system and a user. And of course, there are all these automatic analysis methods like machine learning, statistical methods that we need to integrate to really have a full notion of these visual analytics of time-oriented data. And all these things, of course, need to be intertwined. So now, if we are standing in front of the problem that we have some data, that we have a problem, a domain problem in front of us with a couple of domain users, question is, how do we arrive at a appropriate solution as a visualization researcher? And what I wanted to put forward is a very simple, like three-step framework. Along that, I will explain like how these different time characteristics really play a distinctive role on that choosing. And it's the what, why, how framework. So what does it mean, that what is it that we talk about? So what is the time and the data? What are the time characteristics? What are the data characteristics? And these different characteristics also prescribe some of the visual representation techniques that we actually can use. Secondly, it's of course about the why. So why are we going to visualize the data in the first place? So there is a special group of users that need that, who have some tasks and goals in their mind. And we want to support those tasks and goals in the best possible way. Thirdly, the question is how. So what are the means that we have in our hands? What are the principal ways of how to visualize time and integrate also interactive means in all that. And I will walk us through these three steps and give you a couple of examples of what that actually means. So starting with the first item here, what? So what is it? Time and data characteristics. There are actually quite a few of these modeling time characteristics. Don't worry, I don't go into every single detail of them. I just pick out one or the other just to make the point here. On the first level of when we look into how it is possible to model time, we can look at scale, scope, arrangement, and viewpoint, and pick out just one here, which is arrangement. So what does that mean, arrangement? So time can be arranged or can be seen linearly or in a cyclic manner. So when you think about time, you can think about it like in a pretty linear manner, like from the past to the present to the future, would be like this linear view. Most of the time series data that we can think of is mostly in this notion and has this connection to this linear succession of time. On the other hand, we also do have quite a bit of cyclic phenomena in time. You think the season of the year, the days of the week, the month of the year, etc. So we have things that reoccur that are important for like looking at patterns that are very often tied to the cyclic like nature of this data. So we can see time linearly, cyclically, or even both. So in many cases, also the combined notion here is necessary to look at. So and what does that actually mean for the visual representations? So if we look at linear time, we need specific visualization techniques that are able to like really represent that linear notion of time. What you see here is just one example. It's called a time wheel representation technique. We have a multivariate data set around here, a circumference for variable 1 to 5. And in the middle, we have like a time scale as a time arrow that shows time linearly and connects time to the different variables. But if we have a cyclic notion of time, there might be other visualization techniques that are better suited to communicate that cycles that we have in time. So that's an example of a circular silhouette plot that makes these circles and these recurring like granularities that are within that circle better visible than the others. So depending on the characteristic of the time we're using, one or the other visualization technique might be better or less suited for our application case. So I've just gave you the example of that notion of arrangement. As you see, there are like all the others as well, like scale, scope, and viewpoint that bring in other things like, do we know how much time there is between the data elements? Do we look at point-based or interval-based scopes on the time scales? And do we have maybe things like branching time, which means that if we talk about future planning, there might be different scenarios. Depending on like, a decision you take at a certain point in time, you might have different alternatives that could come true in the future, but you want to visualize them and compare them. So that could be a case. So there are other visualization techniques better suited for this notion of time. But that's not all. If we think about time, we also oftentimes need to take into account these abstractions. So granularity in calendars, time primitives, as well as determinacy. And picking out the notion of time primitives, in this case, I wanted to highlight mainly this distinction of instants and intervals. Where an instant is like a point in time. So we're looking at like point phenomena, so to say, in time, so moments in time. Intervals, on the other hand, they have a start point and ending point, a duration in between. So think about like tasks in a project management manner, for example. So you start an activity at some point in time, it has some duration, it ends at another point in time. And these different time primitives, they prescribe different representation techniques. So many of the visualization techniques that we think of when we think about visualization of time-related data actually mainly focused on visualizing instant data, so time points. So what you see here is a technique called TACO, table comparison, where a table or the changes of a table over time can be visualized and explored. And you have like certain points in time at which you compare those tables. So this is this point-based notion. On the other hand, if you think about interval data, I mean, a classical example are like Gantt charts, as the one you see here for project management, where you have different activities, different tasks that can be also hierarchically clustered within each other. And they have a beginning, an end, and a duration that results from that. So that was bit of information about time primitives. What I didn't talk about here is the span. A span means just a duration, so it's just 3 hours, but it's not like located absolutely on the time domain. So that's another time primitives we have in there that can be used. Other things are granularity in calendars, where we could have no granularities, or just one single granularity, which could be seconds, minutes, milliseconds, or multiple granularities, which is the case we often have to deal with. So we know that there's like 60 seconds make up a minute and so on, and you can go up like to weeks. And then the problem starts. So because weeks don't fit properly into month, and so we have to have these irregularities in the mappings in between. And we have the years, we have the years that have 366 days versus 365 days. We have different time zones. So all these things add to the complexity we have to deal with in this notion of granularity in calendars. And the other thing is the so-called determinacy, or like uncertainty might be a word easier to explain. So do we have certain information about the timing of some data object? Then it's determinate. Or do we have some uncertainties? So if we don't exactly know when something happened, we also need a way to model that in our data. Or if we talk about the future, more often than not, we're not sure how long, for example, a project management task will be taking us. So often when we think about this planning tasks, we probably would say, okay, we need like 2 to 3 days to finish something. But this 2 to 3 is nothing that can be easily represented. If you think about this Gantt chart example I had before, you have a bar with a distinct beginning and a distinct ending. So how to visually express if there is, for example, an uncertainty about this duration. So we talked about time so far. Of course, there is this data that is tied to time, and a very simple set of characteristics that includes scale, frame of reference, kind of data, number of variables. Just wanted to briefly highlight 2 of them, which are frame of reference and the number of variables. So frame of reference, we can distinguish between 2 things. We can have abstract data, so without any relationship to another like physical dimension, or very often we do have also spatial dimensions. So we have a relationship to, for example, some geospatial positions over time. And this, of course, also leads to different representation techniques that are suitable for that. So here you see an enhanced interactive spiral display that uses 2-tone pseudocoloring for representing quantitative data, but it is not tied to any like spatial position. On the other hand, you see here a helix icons representation. So where you have a base map, and based on the different regions on that map, time-related data is represented in this sense here as 3-dimensional helix icons. And the second notion is, of course, the number of variables that often makes this selection of visualization techniques challenging. So we either have like single variables that have some different quantities, for example, or if you have multivariate data, so multiple variables, or even go a step further, having multiple variables with like heterogeneous data types. Talking about the first, so this like tile maps display is a good example for that. So we have like one variable, which could be a temperature, or in this case, it's an ozone measurement in a city. And we have these like per day, we have these measurements that are represented. So it's one variable, it's ozone concentration. Or if we have multiple variables, we need other visualization techniques. In this case, what is shown here, it's called CSIG-VIS tube. So we have these 3-dimensional representation where you see like 7 variables like at every slice there, and the 3rd dimension is then time. So then we see like how these like multivariate like data is changing also over time. So talked about this frame of reference, like abstract versus spatial, and the number of variables, univariate and multivariate. Apart from that, we can also, of course, look at scale. Do we have quantitative or qualitative data? And what kind of data do we measure? Are we measuring events? So just changes in the data, or states. For example, usually in sensors, you would get like sensor readings at a regular pace. So, and even though the value doesn't change, you would get the same value for a couple of times if you measure it regularly. That would be this notion of states. So we talked about time, we talked about data, and of course, these 2 things need to be combined. That's the last thing about the characteristics I just wanted to briefly mention here. And when relating data and time, we can distinguish like 2 perspectives here. The one is internal time. So time inside the data set, so to say, and external time, so time extrinsic to the data model. So when you look into the data itself, it can have a relation to time. So it can have time stamps, for example. So that would be temporal data. Or if it doesn't have it, it's non-temporal. When you look on the data set kind of from the outside, it can be static or dynamic. So what does that mean? So static means like the data set is there, doesn't change. And dynamic data, so the data set itself would be also changing. So it could always just be there, like reflecting one price of a single product, but every time that price changes, the data set itself is updated, but no history is kept. So that would be non-temporal dynamic data. So that would be an example for this. So as you've hopefully seen here, there are quite a number of different characteristics, and they are very unique also to time-oriented data. So there are not many of them who would be applicable to other types of data. So that makes it also special to think about the visualization and the analysis of time-oriented data. So far we have talked about this what notion of what is it about time and data that makes it special. Next up, just very briefly, users and tasks. I will not go into detail on that, just to give you an overview what it means. So when we talk about user task, or when we talk about like going into such a project or providing a solution, we need to think about certain things. So of course, we need to be clear about who will our users be, and what are they doing? What goals do they have? Do we want to explore, describe, explain, confirm, or present something? And different visualization and analysis techniques will be more or less suitable for each of these different goals. The analytical questions are very useful because they're more concrete here. So do we want to help the users in answering those questions? They can be grouped into elementary and some synoptic questions, and usually like identify, locate, compare. This would more be like the elementary ones. And on the synoptic level, it's about sets or groups of data. So is there a group there? Are there correlations? Are there any trends in the data? Do we see outliers? Or do we want to support these analytical tasks actually? Where in the data do we have to or do we want to support these tasks? And what are the means that we want to support that? So could be visual means, could be interactive means. So the visualization itself helps in answering the tasks. Is it an interaction techniques that helps to, for example, find outliers? Or is it a computational technique? So like a statistical technique, for example, that calculates some of these targets of the analytical questions. So we are here now in the middle of this framework of what, why, and of course, like the core element for us visualization people is thinking about how can we visualize and how can we provide interaction techniques for this kind of data. So in principle, like there are two basic routes I can take when I think about the representation of time. So that the first one is like the kind of easier because there is not a translation between concepts, which would be the dynamic representation, where I map time in the data to physical time in the representation, or in other words, animation. So if I have a dot in a two-dimensional Cartesian plot where that relates two variables at one point in time, and I can make that point moving over time, reflecting like the change of that data point over time. So on the one hand, that's easier to grasp because I don't have to like have this translation of concepts in my head because I use time and time here and there. However, what I cannot very much support is things like comparing between different time points because I have to memorize things because they are gone, because the visualization changes if time progresses. Static, on the other hand, is the like most known visualization techniques. They use this static mapping where I use usually one of the display dimensions, like the x-axis, for example, to represent time. So time is then here mapped to space, where I use then one of the spatial dimensions here to represent time. And based on these like basic decision on which route to go for the mapping of time, there are of course a set of visual variables that are known from visualization theory and also all the other visualization techniques that I can also readily use to represent time. Things like position along an axis, the length, for example, to represent a span, angle, as we know from analog clocks, like slopes, connections between points in a scatter plot, for example, thickness or transparency that changes. All these could reflect time in a visual representation. And this gives us like all the building blocks we need basically for like producing different visualization techniques that are capable of representing time-related data. And here's just a like random pick of different visualization techniques that exhibit different notions, like dynamic techniques, static ones, pixel-based visualizations, multivariate, univariate techniques, ones that support linear time, others that support cyclic time, or even ones that combine both, like the cycle plot on the lower right here, which gives you the support for both trend and cycle analysis. So how can you then get like practical help when choosing such a visualization technique? What we've built also as a companion to our book is this website, TimeViz.net, and especially this interactive browser, browser.timeviz.net. Please forgive me when you go there now. We have a technical issue since yesterday. We're about to fix it, so it should be available in like any hour, hopefully, that is getting fixed there. What is there, and what you see here is also a preview already for the second version, for the second edition of the book, is that you have an interactive browser where you can select the characteristics of the data you are looking at, that you want to represent. So, and if you want to, zoom in here, we can focus exactly on the points I just highlighted before. So if you have time points in your data, and you can select techniques that have the capability to represent time points. If I have intervals, I can select this one. Or if I want to hide techniques that support intervals because I don't have intervals in my data, then I can just like hide those techniques. I can select linear cyclic arrangement, number of variables, the frame of reference, and I can also like choose then different mappings of time, as we just discussed, so static or dynamic mappings, or the dimensionality, so two-dimensional techniques or three-dimensional visualization techniques. And as soon as you select some of these criteria here, of these characteristics, the set of suitable visualization techniques will get filtered down, and you would get us a result list. So just try to show you how that thing looks like. So we have more than 100 techniques in here now. That will be ramped up quite a bit also with the second version. And if I want to have, for example, visualization techniques for spatial data, don't want to see abstract data here, and I want to have linear and interval data, you see that there is a smaller couple of visualization techniques that is capable of representing these data characteristics. And if I select one of these, it could be a space-time path or space-time cube. You get a little description. You get a screenshot of the technique. You can like navigate through the others, and then you get also references to the publications that describe those techniques in more detail. Okay. Good. So just to recap where we are, so I've just tried to walk you through this easy framework of what by how. Like first of all, thinking about what the data is about in terms of the data and the time characteristics. What are the tasks? Who are the users that we want to support? And then the decision is how we want to visualize and which interaction techniques we want to provide. And I've also shown you this TimeViz browser that's online available that can help you in selecting candidate sets of appropriate visualization techniques, then and then have been, then they need to be filtered down further, informed by, for example, the technology you can use, the user groups, and the tasks. And to give you an example of recent research and how that fits into this notion of the framework and also the characteristics, I wanted to show you a visualization of flows in dynamic networks that came out of two research projects, SEVA, Self-Explanatory Visual Analytics, which is a still running project, and a recently concluded project called VALID, or Visual Analytics in Data-Driven Journalism, that we've conducted together with colleagues from the University of Applied Sciences, Joanneum, University of Vienna, and the company Radwarenhandel. So what did we look at here? So as I said, the framework is what, why, how. So what's the data? What are the time characteristics here? What this data has is we have networks. So we have flows between nodes. So for example, we looked into this data set called Media Transparency Database, which shows how public institutions, or how much money public institutions give to different media outlets for advertisements, for example. So we do have a network. We have flows between the network, can be money, could be people, could be like anything else that is flowing between those nodes. And we don't only have that like for one time point or time slice, we have that for multiple. So that network basically changes over time. So we have the network structure, we have those flows between the nodes, money, persons, etc. And we have the changes of the network over time, which make it already a quite complex representation technique. And if you think about like commercial tools that are available, like Tableau, Power BI, and you name it, and they're all not pretty much or pretty well suited for representing such kind of data. Not even like a single slice in that network, let alone like the temporal changes there. So examples for applications of that could be like investigating, for example, migration flows over time, like between countries, for example, financial aid between other entities, development aid, or traffic flows between different districts, for example. This could all be examples for that. And like I just put out one of the example data sets that we also use there. In this case, it's about commuting. So between different districts here. And what we look here about is like commuting between 4 cities in Lower Austria in over a period of 8 years. So there are 2,000 data items, which doesn't look that much. However, if you look at the raw data and you look at the scroll bar up there, you see, okay, you don't see very much of that whole data set. It doesn't give you any clue about like how this network looks like and how this changes over time. So what we have done in the course of that approximately 4-year project is what we call like the design study research project. So we started off with like requirements and task analysis, where we did interviews with the domain experts to learn about like their work context, about like what their requirements are, what their goals and tasks are. So this aspect of the why in the framework that we talked about, and also learn about the data, so the what aspect there. We did different conceptual designs, had like expert reviews in between. So it's a highly human-centered, human-centric design process that we followed there. Then we continued with like interactive prototyping. We had workshops with participants, and then we got feedback from these workshops, did evaluations, did iterations on the prototyping. So we have like 3 iterations on the prototype itself. We even did diary studies of domain experts that used it over a longer period of time. And the 4th workshop there, and leading us to a reflection and bug fixing phase at the end of the development of this NetFlower prototype. So relating back to what I've talked to at the beginning, so what are we looking at for this project in terms of time and data? So We talked about the arrangement. So we have linear time in this case. So we have a network and that changes. So we don't have any cyclic phenomena in there that we're interested in. In terms of the time primitives, we have instants. So we have points in time where we kind of have this network, and then we have the next point in time. The frame of reference is abstract, so we don't want to show it like in relation to a geospatial position on a map. That is also one of the learnings of the interviews. That's nothing that on a map that would be interesting. It's more like the abstract view of that. And we have multiple variables, so we can have quantities between the nodes, but we can also have attributes in addition to that for the nodes and also for the flows between the nodes. And looking at the Y aspect, so that largely came out of the interviews that we did with the domain experts there. So who are the users? In our case, we mainly talked to journalists wanting to analyze data with their main goals of exploring a data set like this media transparency database that gives information about money flows between public institutions and private media companies, for example, and also maybe confirm their hypotheses. They might have any hypotheses about, like, is there a relationship between, there is a new government now, do the money flows change in any way between those times? And analytical questions, they were interested in quite a bit, kind of all, like, span the whole spectrum here, from identify, locate, compare, grouping, correlating, trends, and outliers. They were interested mainly in all these things. And the means that we can give them are maybe visual and interactive. In this case, we didn't include any like automated analysis methods. And in addition to this like more formal requirements, we had also the user requirements from on their end. So when talking to these specialists, they were expressing a number of requirements that we then grouped and put forward as the goals of our own design. So first of all, ease of use. So traditional chart types were preferred. Managing a large number of nodes, to a couple of thousands or even 100,000s of money flows, for example, to be analyzed. They wanted, of course, to show or to explore the development over time. They wanted to have a simple data import, which is something that we rarely think about as visualization researchers. We're more like focusing on how to represent, how to interact with, but how to get the data in an easy way is often like not part of our projects. And also the other end, of course, exporting the results. If we like interact visualization, if we filter down to a smaller set of data to some interesting pattern, for example, to how to get out that data that we filtered down, how to export the results. And thirdly, also the analytical provenance. So they wanted to have some kind of trace of what they did and how they arrived at the answers or at the insights they then wanted to publish in articles in newspapers, for example. And lastly, also something that might be not that obvious is data protection. So they were very varied that data they are analyzing are not like leaving their computer, so that should be all on your own machine, not on any server. So that was also a concern that was put forward by the experts. And what we created then is a prototype based on web technologies, like mainly around JavaScript D3 technology. And you can also access that prototype using this URL, netflower.fhstp.ac.at. And it like that's the page that you will see when you open the thing. You get some introductory information about what it's about and how to use it. And the main representation here uses so-called Sankey diagrams, so showing flows between nodes here. So in this case, we have this commuter data that you see in the screenshot. So between St. Polten and so within St. Polten, so how many people travel there for commuting to work. And it's highly interactive. So if you hover over different parts and select, you get additional information. And in addition to that, for each of the nodes, you get the temporal changes here. So you see, in this case, there's not much going on over time, so not much change here. Or also if you like click on one of these flows between the nodes, you'll see how that flow changes over time. In this case, it's yearly data, so from 2009 to 2017. For example, here you have like an outlier in 2015, for example, that was much higher than the data points before and after in time. So, and if it works technically, I can also show you a very quick demo of the prototype. So as I said, so if you open a page, you will arrive at this first introductory page that also gives you textual information, screenshot, and also short video that explains how to use it. And if you then click on Use It Now, you are brought to the main interface, which would then look like this. So what I've loaded here is this media transparency data set that I've already explained. So money flows between public institutions and media, so could be a TV station or a newspaper. And for each of those, you also, for each of the nodes, if you hover over them, you see how the money flow changed over time. And also on the end of the receiving institution, you see how that changes over time. You can then, by clicking on one of the nodes, you can open the details about how that that money flow, for example, changes over time, which is interesting to see here. Is we have data, quarterly data, quarter 1, 2, 3, 4. You always see that's always like going up. It's always kind of the same pattern that you see here. And which could also be a hint that like offering some kind of cyclic representation could be beneficial for that kind of data, for example. You can filter like along different of these time points that are in the data. You can sort, in this case, it's sorted by flow. So the largest flow is on top. And we show the first couple of entries basically to not overload the screen. In this case, it's 12 of the more than 3,000 flows are shown, and it can, by clicking on show more data will be loaded. And I see the first 24 in this case of the different flows. I can change the ordering, as I said, from like source. So then I see like who are the nodes who spend most money. So that would be, in this case, it would be City of Vienna, who spends most to different media outlets. Or I can also sort by target. So who gets most will then be on top here. It's one of the newspapers. Then there's a TV station on the second place here. So that's all you can see there. And then there are also like connection filters. You can have attributes on the flows that you can also tick on or off to filter down the data. You can export the data you just see here, or you can also get an SVG, so a graphics file of the Sankey diagram you see here as an export to be used in something else then. And of course, yes, you have the classical filters on the quantities, on the institutions, on the legal entities that you can apply here. You can very easily either pick another example data set we have here in the sample data, or just upload your own data or point to a URL where your data is, if it fulfills this very simple format and a CSV manner, source, target, time, value. Then you can add as many tags as you want or attributes. Then you can import that and analyze that readily with that tool. Okay, going back to my slides here. So when we reflected on the whole topic, we came to play out that this iterative process very well fitted with the domain experts, and we could characterize a common workflow in the way that journalists integrate this data analysis process into their daily work. So starting from an introduction and onboarding, and also this data import process, they spend time visually exploring the data set, also producing provenance information, so to have a trace of what they did, and then exporting their findings. So the main task is for them is story finding. So they want to write an article about something that is data-based, and so they want to find out something about that data. So it was never intended that these visual representations end up on the website of a newspaper or like in a printed newspaper. It's more like for the journalists themselves to find out new stories and come up with interesting new things. And the second research project I just briefly wanted to, talk about is the project CSIG-VIS, and especially that's one prototype that we just very recently at the CSIG-VIS presented. It's called Soniscope, where time is used in a very different way. So first of all, like this whole project is about combining visualization with sonification. So making data audible. So having like audio representations of data and combining that with the visual representations to have more of the perceptual capabilities of a human being at disposal so that we can use that for the data analysis. And the Soniscope, so the basic idea is that we took like this medical device of a stethoscope as an inspiration. And we also wanted to build a framework for our own research because we were prior to that building up some theory about this combination, so a combined theory of audio-visual analytics. And this should also be like a test bed for our ideas there. And the idea is kind of as a physician would use the stethoscope to listen into different body parts, that you as a data analyst could use the Soniscope to listen into different parts of your visualization. In this case, we took the example of a scatter plot, but it could be any visualization, basically. It's about this principle of using kind of an interactive lens that gives you then additional information using a different modality, as in this case, the sonification. And sonification in respect to time, it also uses time as the substrate of the representation. Whereas usually with visualization, we use space as the substrate. So either a position on a 2D plane or on a 3D representational space. For sonification, we need time as the substrate. And then we put different audio features along the time scale. And as an illustrating example, we took a data set about bike rentals, basically, that we found publicly. For example, what you see here is you have a timestamp, but you also have additional temporal information, so which relates it also to our main topic here. We have the season, the year, the month, if it's a holiday or not, if it's a weekday, if it's a working day. You have temperature in each day. We have humidity. And we have a count of how many bikes were rented at each day. And that's, for example, something that we wanted to explore. So if, for example, we had this hypothesis, okay, if it gets warmer, then more bikes are getting rented. But maybe there is a point where it gets too hot and this levels off again. And again, putting on this lens of the framework that I have introduced at the beginning. In this case, we have a linear plus cyclic arrangement of the data. As you have seen, these different temporal granularities that we have there. In terms of time primitives, we have days. So we have these time points as days. The frame of reference is abstract. So it's kind of one geographic location that we look at, not different ones. And we have multiple variables also. We had, for example, temperature, humidity, and so on. And the basic idea is that we created this exploratory environment using Jupyter notebooks, where we integrated a sonification toolkit with representation based on D3. And the idea is that you can steer the mapping as a user. So you can decide what goes on the axis, for example, and you can steer the mapping to the sonification. So what gets mapped to pitch and what is the sorting variable that gives you the order in the temporal domain. And then there are a couple of other interactive means to steer the lens size, the scan duration, or the shape of the lens. You see here this mapping of the x-axis. You see the y-axis is humidity. Pitch is then represented only audible. So that's nothing you would see. That's only like how high a tone would be that is played. And the sorting is then here what is the sorting over time. In this case, it is by temperature. I just show you a couple of, or wanted to give you the opportunity to listen into a couple of snippets of the demo video here. So as I said, you can, as a user, select the different variables that you want to see and also hear. And then you have this lens that you can also change the lens size or the form as well, if it's only over the x-axis or over the y-axis. And as soon as you then click into the visualization, then the sonification which will get started. Okay, I'm gonna stop it here as the video takes too long. The basic idea is, I mean, as you've seen while listening to it, it's quite unusual for us to use also our audio channel for data analysis. But if you take the time and sit there for a couple of times and really try to listen into it, it's quite amazing how much differences and patterns you can hear, which might be not that easily be seen visually. So this audio channel can add a lot of value also, especially in combination with a visual representation, and opens a lot of new possibilities. So that's a really very interesting new research area we're currently working on, and that's also an introduction to you. We are in the process also of creating what we call the audiovisual analytics community, where we work together with partners from Graz, Linköping, Maryland, and also from Atlanta. And this has multiple points. So the idea is to bring together a group of people interested in combining visualization and sonification and creating new tools, new things, new interesting, also installations, if you will. And what we do is we do bi-monthly online meetups that we run via Zoom, where projects are presented and discussed. With this online community that we run via Discord and as a mailing list. And also we did already a number of workshops at international conferences, like at the Audio Mostly last year, at the CSIG-VIS last year, this year at the AVI conference. And we will have an application spotlight at CSIG-VIS 22 in fall as well. So if you're interested, go to that website, Audiovisual Analytics, GitHub.io. And or contact also Kajetan Enge, who is coordinating that whole effort to be put on the mailing list and also on the Discord server. So with that, I would like to wrap up. So I tried to show you a bit of the complexity of time and why it's worthwhile to think about it and why it makes a difference of what time characteristics I look at in terms of the visual representations that are suitable for those different types of data. I didn't talk that much about interaction. We've seen a little bit about newer forms of interactivity shown in this Soniscope project I showed at the very last, and also the analytical side of things. There are also time concepts of interval analysis, multivariate sequence analysis and stuff like that. That is very interesting, and there are special methods needed to take into account the special characteristics of time if the data needs to be analyzed in a good way. So maybe as a list of challenges of things that we're currently working on, or also things that I see that are still relevant and will be still in the future, are questions around data quality. So how can we effectively detect and communicate and also correct quality issues? But it is, as you all know, if you've worked with like real world data, it's all messy, it's all dirty. In a way, you have to transform it, you have to cleanse it. And there is a good place for visual analytics techniques to support essentially this issue of data transformation, data cleansing in the notion of data quality. Knowledge-assisted visual analytics is also a topic dear to my heart. I haven't given you examples of our research there. The idea is there to like bring some of the domain knowledge of your users into the systems. So how can the visual analytics process benefit from externalized and shared knowledge of analysts? So if I can take over some of the domain knowledge in the visualization or in the interaction or in the analytical techniques, I have a much better analysis system. Visualization literacy and onboarding, I hinted a bit to it in the context of our NetFlower prototype. So how can we best support users in understanding and successfully working with visual analytics tools? So newer representations that you might not be so familiar with, how can I bring domain experts up to speed in the fastest way that they can really work and understand what they see in front of them and really take full advantage of the power of that visual analytics tools? And lastly, another topic, situated visualization. So how can we make data visible that is sensed maybe in your physical context around you, like outside? You maybe have sensors of environmental data, but you don't see it where it is sensed. And the idea of that situated visualization is make the data visible in its physical context where it's actually recorded. With that, I wanted to conclude and say thank you for giving me the opportunity to talk to you. I wanted to show you a good glimpse of these distinct characteristics that time has and the data that is tied to time. I hope that I gave you a good overview of that framework for selecting appropriate visualization techniques. And the idea was also to give you some illustrating examples of current research that takes into account these different aspects. Another pointer to our hopefully soon again up website, browser TimeViz.net, that you might find useful in your own projects. Okay, thank you very much.
Thank you so much for the interesting talk. And I learned a lot, and I think the audience also share the same idea with me. All right, so there are some questions. I received several questions actually. So the first question is that the display of temporal data can be static, like time slices, or dynamic, for example, like animation. So from your view, what are the advantages and disadvantages of each of these two approaches? Example, for example, is like exploring air pollution data containing, for example, geographical information for a certain time period. So do you think it is better to show the change in pollutants over the time period using animations, or it is better to represent it through something like a horizontal graph?
Yeah, thank you for the very good question. It very much captures nicely also like the aspects that I talked about. And like the short answer is it depends. So kind of depends mainly like on the second stage of the framework on why, right? So what are the analytical goals and questions you want to support? And if we take that example, so maybe in general, so like pros and cons I see for both approaches there, like animation, as I said, so it's the pro is there is no like change of like dimension. So time is mapped to time again if I use animation. And the pro also of animation is it better fits to if I want to have a narrative in there, if I want to tell a story, if I want to guide you through something, and I want to present something. For that, animation is better suited. For the more exploratory approach, if I don't know yet what is in the data, if I wanna give you some tool in your hand that you can like compare data developments, then the static mapping is often a better choice because it doesn't require me to remember like if there is an animation, the picture changes. If I stop it at something, even if it's an animation that I can stop it there, I only see what is there now. And then I have to like go back and forth, and it also needs to be done in my brain, basically.
Exactly.
But if I have a static mapping, I have both points of different times in my view, and I can directly, for example, compare those.
Yeah, exactly. Yeah, great. Okay, so the second question is about provenance data. All right. So, for example, like provenance data for the data storytelling, interactive storytelling. So, for example, like data exploration, when we explore the data, we record all the events through the exploration, and we use a timeline to connect them. Well, at some moment, the timeline will become very long, and then our display cannot fit anymore. So, do you have any solution to this?
Yeah, I mean, in the sense, I mean, we took an easier route when we designed this NetFlower tool, to be honest. So what we did is that provenance was more like kind of a diary style. So you would be able to put in like direct links to the status of the tool itself, but the rest is more like freeform. It was not automatically captured. Provenance information. So in this case, the user itself like took the provenance and like noted down the steps. But there are forms of provenance and provenance tracking that are done automatically. Like for example, like Mark Streit's group or Alex Lex, and they're working on these topics, like on automatically tracing that provenance information, and also working on these questions of like simplifying and grouping, as of course you're completely right. Exactly. So that could explode on you if you like every single thing, every like mouse movement, and you track everything. Yes. The question is what is important and what makes like larger steps visible, and what can be left aside. Yeah, exactly. It will be always quite difficult to decide what is important, and sometimes you cannot find an important node from the timeline. Well, yeah, so this is still an open question. Yes. All right. Okay, so the third question is about immersive development. All right. So the previously temporal visualizations were used on traditional output devices like a laptop or tablets. Well, now more and more types of visualizations are trying to be presented in the immersive development, like VR and AR. So the audience is curious that what types of temporal data or what types of analytical tasks about temporal data do you think might be more potential in an immersive development? So how to visualize time in the immersive development? Yes, I mean that's also an excellent question, as it's also like the topic of one of our current research projects, for example. And there is not so much work in that area, to be honest. So I mean, it's all the technology is quite new or affordable in a way that you can really experiment with that in representing time-oriented data in this respect. And we have the tools available. And it's often about these technical difficulties and to overcome them. And we see that in this project now also. It's like selecting like a suitable development environment, like the target devices and so on. So it's a lot about getting the things right and the location and setting it up in outdoors environments and getting the precision for your location to reflect like the overlap to the real world outside. If you take AR as an example, there are better ways already, like in a VR environment indoors, where you have these tracking systems and you position yourself. And I see a couple of interesting challenges there. The one thing is not so much tied to time-oriented data especially, but in general, it's more like if you have like an AR visual representation, like where you see your actual surroundings still, and you overlay data representations, like I sketched with the situated visualization example there. The question is how can I do that in a way that doesn't like obstruct everything I see out there, that it nicely blends with like the outside environment. And of course, when oftentimes we use like two-dimensional representation techniques, but we look at a three-dimensional world, right? So how can we integrate these things? And we can use this in a way that it's more like a focusable context, kind of a fisheye representation. Like if we tilt something, it could be like on a virtual wall. If you look at it from an immersive environment, it takes up less like absolute space of your like whole viewpoint there. That's a thing. The other thing, more tied to time-oriented data, is you could think about that when you move yourself in the environment or also in a room, that you then navigate time by moving. So that could be something that you cannot do like on a screen easily. Okay, you could like walk through time in your data virtually if you're like thinking about an immersive visualization environment for such data.
This is very interesting topic actually. Why because in the immersive environment, for example, VR, and you are together with data, probably also together with your collaborators.
Exactly. Yeah.
Well, yeah. So it's a very interesting topic, I think. Okay. So next question is about human-centric design. So you mentioned that you used a human-centric design process for the design study of the time visualization. Well, I can expect that because this is a very interesting topic, and people will be very creative. They have very different ideas. So how did you conduct this interview or workshop? Or so how did you like motivate them to tell the interesting ideas, but also constrain them their ideas?
Yeah, I mean it's not so easy, right? So I mean it is very important, and I try to do it in all of the projects that we are doing. Is really like designing, constructing these things around the needs and the requirements of the actual end users, and like going there. But as you're right, so if you have user groups that are not regularly using, for example, any like visualization environments or any like tool in that direction, they might not know what they actually can expect or what they need. So you need to like scaffold a bit the discussion there. So what we usually tend to do is also to bring examples, right? So we focus on a more specific area. Like in this case, we had this notion of the dynamic networks that change over time. And we were giving them examples of what could that be like in your realm. So it could be like looking into migration flows, for example, which is a topic that's often used by journalists, and analyzing of where people migrate between countries and how that changes over time, and giving them like a perspective of, okay, you would do much better if you would have a visual analytic tool that would support you in analyzing data, rather than like using Excel or any like very low level analytics tool there. And in our case, those were also people like coming from journalism, right? And not from data analysis in any way, or computer science, who were mainly non-technical people. So and like getting them where they are right now, and showing them, but also like really having examples of visualization and showing them, okay, these things you can see by the visualization, you wouldn't be able to see easily when just opening it in some spreadsheet program, for example. So that's the one thing. And we did a couple of interviews, and that we qualitatively analyzed these results. So we audio taped everything, we took notes, and then we put the things together and distilled also this list of design requirements and design this data of things they wanted to fulfill. Then there were these lo-fi sketches, and with those we already went back again to specialists to give us feedback if that's like going in the right direction, and doing some improvements based on that. And the workshops you mentioned, we then had a working prototype. As soon as you have something like a working prototype, we went out also to practitioners, like told them about like what data-driven journalism is and what tools could you use, and also presented the status of the prototype that we had, and gave them example data sets, or like encouraged them to like create their own, and try to work at least for like 1 or 2 hours with that prototype, and we would be like observing them. So like also looking at what questions they ask, where they struggled, what did they understand, what did they find out, what feedback, we explicitly ask for feedback and like hints for improvements, and that process kind of iteratively developed over time, and we have a couple of iterations of where we change different things and representations and interactions until we arrived at the status that I've shown today in that prototype.
Mm-hmm. So how many people will be involved in the design process?
You mean the people who interviewed or the people who created it?
Yeah, so both.
I mean, the initial interview, like I think there were like 4 to 6 like experts that we started off with, like the qualitative interviews, like 1 hour each. Then we had these 2 to 3 like expert feedbacks, and with these empowerment workshops, there were like in the dozens. We have had 4 of these workshops, and in each time we had like 10 to 15 participants in approximately. And on the development sides, we mainly had like a group of 3 researchers, like in the core development team, like doing the design and also the implementation. That was kind of the team. Yeah.
I see. Okay, thank you. So next question is very interesting work, the Stony Scope view. It's very interesting. We also did similar thing, user study. Okay, well, and so the first question is who will be the potential users?
Of which prototype are we talking about?
The Stony Scope.
The Stony Scope, the sonification.
Yeah.
Yes, I mean, in this case, we took a different route. That's exactly the point here. So in this case, we didn't like do any user research up front. Yeah. So basically, in this case, we came from the other direction. So it was theory based. So we first like developed kind of a theoretical model of how can we capture both modalities under one roof. Because we have those 2 communities of the sonification community, the visualization community, they developed pretty independently, had their own theories, and they were not very compatible to each other. And so the first step we took there is to come up with some like theoretical underpinnings. And then we said, okay, we need to validate, we need to like make that like actionable in a way. And so the next step was here to create these prototype or this prototypical environment. It's also kind of a prototypical environment for ourselves to test our like assumptions and create something and have an environment that allows that in an easier way. So that's why we created that inside this Jupyter notebook using Python and JavaScript and other components to put that together. I mean, the user group there is not fixed, right? So, but any like exploratory goal that we have for analysts that take into account a larger number of variables, put it in that more abstract way, those are the areas where I think it has most potential. To exactly because it's also highly interactive and iterative process. If you think about this lens and you have to compare and compare things, so it's more about like analysts in a professional environment probably that, for example, I could think of like financial data analysis, for example. There you have a lot of time series, you have a multitude of variables you want to compare over time. I guess for something like that, it could be very valuable to have these more dynamic and active approach for data analysis.
I see. That's a very interesting topic. It's very, very interesting to me. And if you, for example, want to do a user study, because we actually did a user study about the audio and visual and sound and scatter plots. I do the study about this. So if you want to design a user study, what do you expect? How to do this user study? Yeah,
that's actually an currently ongoing discussion that we have internally a lot. We didn't run a study yet. That's kind of our next concrete step there. And I mean, It's, as we already know, if we only take like visualization itself into account, it's also non-trivial to run a proper evaluation. Like, I mean, the one thing is you have these lab studies where you have like a highly controlled environment. You have like screen sizes that are similar. You have the same like interaction environments. Of course, it's even more complicated if you have sonification, because the question is then, do we have loudspeakers? Do we have headphones? So how many of those speakers do we have in what setup? So all these can be controlled. So if you do a lab study, that is easier to be controlled. However, the kind of ecological validity is lower because if I am at my computer in my office, it will be different to somebody else in another office, but it's not really possible to tweak your solution to every possible like work environment there. So it's a fact that these differences are out there. So and the methods you generate should be also valid and useful in those different environments. And that's actually kind of the discussion that we revolve around, right? So and I think it depends also on like what you want to find out, right? So if it's more like you want to have to do some longer term kind of diary-like study to have somebody work on a data analysis of a more complex data set over a longer period of time, I think for that it's useful. You can do it in the individual environments. If you wanna look into the specific differences between, I don't know, using like pitch or tempo or some visual variable and how it affects on how fast I'm able to perceive something, then a controlled study is probably the best choice to make there.
Yes,
but there is still, I mean, there are still very few like best practices and very much open to new research.
Okay, great. Thank you so much. I think I asked all the questions that I received. Okay, so let's thank Professor Aigner again. And can you stop sharing the screen and I can share the screen to introduce the next speaker? Thank you.
Thank you.
So next speaker is Professor Takayuki Ito from Okinawa Autonomous University, and the title is Applications and Evaluations of Hierarchical Graph Visualization, and the time is 7 to 8:30 p.m. July 14. So you're welcome to join us in 2 weeks. And another announcement is today is the last day for the early bird registration for TimeViz 2022. So if you would like to join and attend the TimeViz this year, you should do it today. Tomorrow the registration fee will go up. All right. So let's thank Professor Wolfgang again, and thank you so much for the wonderful talk. I hope you also enjoyed the discussions, and thank you so much for joining us today, and see you in 2 weeks.
Thank you very much, and thank you for the great questions. What a great discussion. Thanks.
Thank you, and
bye.
Yeah, bye-bye.